welcome to our 6 to 8 channel. Today we are doing part 2 of physical and chemical changes. Now, the last time I had put out a session for you and we had spoken about only the physical changes. Today we're going to be talking only about the chemical changes, right? So to all my 7th standards out there, a very, very warm welcome to you. If you're not in the 7th standard, you're in the 6th or the 8th, so what? You can watch and learn too, right? Now, let's do a quick recall of what we did last time. What were some of the things that we discussed in our last time ka session, right? So first of all, we spoke about the fact that there are changes happening all around us. Everywhere we look, there are changes happening, right? Now, we also spoke about what is a change and what are the different sorts of changes that can happen, right? So we spoke namely about 2 kinds of changes. We discussed these. One was a change based on reversibility, right? So you have reversible change and irreversible change. And then we spoke about changes based on the formation of a new substance, right? So if we go back to reversibility, when we spoke about reversibility, it was very simple. Reversible changes are those that can be reversed, and irreversible changes are those which cannot be reversed. Okay, so reversible, irreversible. This we've discussed in detail. I'm not going to discuss this. In case you have any questions, go ahead and watch that session of ours and you will have all those questions answered. Okay? Then we went and we discussed another type of factor in terms of changes, which is basically changes based on the formation of new substances. And here we spoke about 2 different types of changes, physical changes and chemical changes, right? Last time we spoke about physical changes, right? So what did we discuss in terms of physical changes? Well, first of all, we discussed what is a physical change. We said a physical change is one where the physical properties, there is a change in the physical properties of a substance, but there is no new substance that can be formed over here, right? We also said that these changes are reversible. They can be irreversible also. But basically, it is no new substance being formed and a change in the physical properties. What were the physical properties we discussed? It's right here for you to see. We spoke about change of state, which is solid to liquid, liquid to gas, right? We spoke about change of size. We spoke about change of color. We spoke about shape. And we've taken a lot of examples of all of these things. Once again, if there's any question about physical changes, go back and visit that session. I'm not going to be repeating that over here. Okay? Now, what are we going to be talking about today? Well, we're going to be discussing the next sort of change based on the formation of new substances, which is namely chemical changes. We will be discussing this in detail. We will be talking about the characteristics of chemical changes, and we will also be discussing a very important concept that a lot of you have been asking me questions about. This concept is called rusting, which also, by the way, is a chemical change, right? But we're going to discuss this in just a little bit. Okay. Now, like I said, last time we spoke about changes where there is a formation of a new substance. And in this, we discussed 2 types of changes, physical change and chemical change. What is a physical change? Once again, I'm repeating this. Physical change is one where there is a change in the physical properties of a substance, but there is no new substance formed over here, right? Chemical change, on the other hand, is a change in the chemical property or the chemical composition of a substance, and here there is a new substance that is formed. So what are we going to be discussing today? We've already finished physical changes. Today we are going to be discussing chemical changes. Okay? So then, what is a chemical change? I've already explained it, no? Let's discuss this in detail. What is a chemical change? A chemical change is basically a change that alters the chemical properties of a substance and involves the formation of a new substance. So how do you know that a chemical change has happened? Well, there are 2 basic things over here. Number 1 is that there is a change in the chemical properties, right? Not just the physical properties, the chemical properties have changed over here, and basically you have, and because the chemical properties have changed, you've got a completely new substance. This is what we call a chemical change. Now, Examples. There are examples all around us. I mean, if I was to just ask you for an example of chemical changes, I'm sure you'll give me 5 or 10 just like that. But I'll give you some very basic ones that we deal with all the time. Number 1, cooking of food. Now, when you're cooking that yummy bengan ka sabzi, or you're baking that wonderful cake, what are you doing? You're taking some ingredients like in a bengan ka sabzi, which by the way is one of my favorites. And again, we're talking about food and I'm feeling hungry. But okay, back to bengan ka sabzi. What are you doing with the bengan or the brinjal, right? You're taking the brinjal, and then, which is brinjal on its own, and then you're adding some other ingredients like maybe salt, or you're adding onion or whatever. And all these ingredients are currently separate ingredients. Then you introduce heat. And with this heat, you're cooking the sabzi, and what is happening to the sabzi? Basically, the chemical properties of all of these separate ingredients are getting changed, and you've got one new substance over here, which is basically that bengan ka sabzi, or that yummy cake. Yummy cake also will go in probably as, flour or egg or milk or whatever it is, all separate things. Which have their own distinct physical properties or their own distinct chemical properties. And then when you combine them and you put it into the oven, what happens? You've got a completely different thing, a cake. You can't get back your milk and your eggs and all of that. Same way in my bengan sabzi, I can't get back the bengan and the onion and all of that. This is a completely new sabzi over here. So cooking is actually a very good example of a chemical change that we see in our day-to-day lives. Okay, so we've spoken about cooking of food. Then another very common change that we see in terms of chemical changes is how we make our dahi at home, right? So you start off with milk and then you curdle that milk. And then what do you get? The curdling of milk, basically you go from milk to dahi or curd. Now, curd is a completely new substance. The chemical properties of curd are very different from the chemical properties of milk. So what has happened over here? There is a chemical change that has happened over here. The chemical properties are different, and now you have a completely new substance, which is yummy dahi. Do you like dahi? I like dahi very much, especially curd rice. Okay. Now, these are changes that we see around us in our daily lives. Let's talk about some of the changes that we are studying about in our NCERT books, and we can talk about how we can do these in the lab. So, for example, let's talk about a magnesium ribbon, right? Let's say you have a magnesium ribbon and you go ahead and you burn it. Now, we know that burning basically takes place in the presence of oxygen. Without oxygen, you can't burn anything. This is the basic fact, right? Now, what do we have over here? We have magnesium ribbon, which is basically magnesium plus oxygen, and this basically reacts, it burns in the presence of oxygen, and it gives us a completely new product, which is magnesium oxide. So what has happened over here? Chemical properties have changed, and magnesium oxide is a completely new substance. Chemical change, right? Okay, अब हमको magnesium oxide मिल गया. What do we do with this magnesium oxide? Let's go a step further and let's take this magnesium oxide and let us combine it with water. Okay, now when you combine magnesium oxide with water, you get a new substance again, new chemical properties again. What do you get? Magnesium hydroxide, right? So this is really cool again because magnesium hydroxide is a completely new substance. Once again, this is a chemical change. Okay, it's very simple. Chemical properties are changing and a new substance is being formed over here. That's the basic about a chemical change. Nothing much to understand. It's a very simple thing. Okay, chalo. Let's talk about another very common experiment that we talk about in our NCERT books. And you know, if you download the BYJU'S app, you will see that we've spoken about this experiment over here. Let's say that we've got a shiny new iron nail. Okay, and we take this iron nail and we put it into copper sulfate solution. Now, copper sulfate solution starts off as a blue solution. Basically, copper sulfate is blue in color. But when you put that iron nail into copper sulfate solution, there are two changes that happen over here. Number one, that copper sulfate, basically that solution that you have goes from blue color to green color. Why? Because there is a new substance being formed over here. This is a completely new substance. Also, that shiny iron nail that you had, which was silver color, it becomes brown in color. There is a brown sort of deposit that happens on this nail. So what is this chemical change that is happening over here? Let's discuss this, right? So once again, what do we have over here? We've got blue copper sulfate solution. We start off with blue copper sulfate solution. What do? We introduce iron to that, right? So we have copper sulfate, which is blue, all right, plus iron, which then combines as as a chemical change to give us two new substances. This gives us iron sulfate. Iron sulfate is green in color, and that is why you are seeing that color change over there. And that shiny new nail becomes brown in color because there is a copper deposit on that nail. So as a result of this particular chemical reaction, what are we getting? We've got copper sulfate plus iron, which gives us green iron sulfate plus brown color copper, which you see on the nail, right? Now again, how do we know that this is a chemical change? Very simple. Chemical properties are changing, and iron sulfate and copper are both new substances that we have over here, right? Okay, chalo. So we've discussed three things. Basically, we've spoken about magnesium plus oxygen, which will give us magnesium oxide. Then we take that magnesium oxide and we go ahead and we combine it with water. We get magnesium hydroxide. In a completely different experiment, we take copper sulfate and iron. And what do we get? We get iron sulfate and copper. And all of these basically are chemical changes. What is a chemical change? A chemical change is one in which one or more new substances are formed. We started off this discussion only saying that we're talking about a type of change where there is no new formation of substances and formation of new substances. No new formation of substances, physical changes. We did that last time. Formation of new substances, chemical change, which we are doing today. Right? Clear? Okay. Now, we know what a chemical change is, which means chemical properties are changing and we've got a new substance being formed. But are there any characteristics? Like, for example, in physical change, we spoke about some physical properties changing, like change in shape, change in size, change in color. Similarly, for chemical changes, are there any giveaway signs to tell us, ooh, that's a chemical change, right? Are there any characteristics of chemical changes? Well, yes, there are. Let's discuss these. So first of all, I think the most wonderful example that I can give you is patakas, fireworks. So what is happening over here in the fireworks? We're seeing these beautiful lights, different colored lights, and we're seeing there's a lot of heat that is given out over here. There are gases that are given out over here. There is a sound that is given out over here, right? So fireworks is actually a beautiful example of a chemical change. What is happening in terms of the fireworks? Well, you've got different metals over here. These metals are reacting with oxygen to give out these different colors. So we have basically heat, light, radiation, maybe either given off or taken in. Also, pataka sound may be produced over here. A lot of our fireworks have this explosive sound that is happening, and this is why we say these are basically characteristics of the chemical change. So anytime you're thinking of changes, characteristics of chemical changes, a great example to think of is fireworks. In fireworks, there is heat, there is light, there is radiation, and there is sound. Okay? Now, another characteristic of chemical changes could be a change in smell. Now, this could be a good smell or it could be a bad smell. A good smell, this is a good smell. You have the baking of a cake. I love it, when you put in the ingredients and you put it into the oven, and very shortly you get this beautiful aroma of baked bread or baked cake. And this is because the chemical change has happened, right? In some other cases, when we're talking about not so nice smell, when food goes bad, it gives up a really bad smell. Now, that is also a chemical change, right? So, this is another characteristic of chemical changes. So, what have we spoken about so far? Heat, light, sound, radiation, change of smell, right? You could also have change in color. I'll take the example of food getting spoiled. When food gets spoiled, apart from the smell that happens over there, you also have a change in color, right? It just starts looking all greenish and brownish and not very nice, right? So this is because a chemical change is happening over here. You can't get that that fresh food that you started with, or that fresh bread that you started with. If it gets spoiled, you can't get that back, and you definitely see a color change happening over here. So color change is also a characteristic of chemical changes. Clear? Okay. And in some case, you may also have gases that are produced. So for example, a very common example that we keep discussing, which is a really cool example, by the way, I love this experiment, is when you take two really normal substances that you find in the kitchen. You have to please be very careful if you're doing this at home, because there's a lot of everything that comes out like this. There's a lot of gas, and this is the characteristic that we're speaking about. If we take vinegar, okay, and we add baking soda to it, okay, what happens? There's a lot of gas that is released over here, and that's why this fizzing is happening over there. So when you combine vinegar and baking soda, which by the way is you're mixing an acid with a base over here, okay, we've learned about acids and bases over here. When you take vinegar, which is an acid, and you mix it with baking soda, which is a base, what do you happen? We've spoken about neutralization before. We know that we get salt and water, and in this case, carbon dioxide also. Carbon dioxide is the release of a gas, and this fizzing that is happening is an example of a chemical change, and gas is coming out over here. Try this if you've not tried it before, but be careful when you try it. It can make a huge mess. Okay. So we have discussed chemical changes. What is a chemical change? We've taken a lot of examples, daily examples around us. We've talked about examples that we find in our NCERT book also. We've also spoken about characteristics of chemical changes. Now, let's talk about the fact that while we see chemical changes, around us, again, there are a lot of chemical changes that happen around us. Burning, spoiling of food, baking of bread, browning of an apple, all of these are chemical changes. Having said that, are chemical changes good or bad? Well, like most things in this world, some changes can be good, some changes can be bad, right? So when we're talking about the importance or how chemical changes can be used to our advantage, well, there are so many advantages. For example, we have medicines. You're creating medicines. You're taking two different substances. You're combining them to give you a medicine which is actually good for us. So this is a huge important thing, a huge benefit of a chemical change. Or for example, ripening of fruit. You can't eat a kacha fruit, right? But when that apple is tasty and ripe, you're going to eat it. That's also a chemical change. You can't go back from a ripe apple to being an unripe apple. It's a new substance completely. Plastics that we use, detergent that we use, so many uses of chemical changes, right? So yes, chemical changes are very good. They help us in a lot of ways, but then like a lot of other things in life, sometimes there are some things which are not so great. For example, rusting. Rusting is a very common example of a chemical change. Now, generally, when you have some sort of, like an iron or something like that, or metal outside that rusts easily, what is happening? That iron basically is getting corroded. It's rusting over there, where you see the shiny new nail become a brownish sort of substance on it. This is the process of rusting. Now, rusting is a chemical change. So, when we're talking about rusting, we know that rusting is a chemical change, but what is rusting? Okay, let's discuss this. So, rusting, basically, when we're talking about rusting of iron, we start off, like I said, with shiny new iron, okay? And then what happens over a period of time? You leave that iron out, and obviously, you leave it out in the air, exposed to air. Now, air has oxygen, right? So, it has oxygen and it has moisture, which is basically water. When you expose iron for a long period of time to oxygen and water, or oxygen and moisture, so basically damp air which has oxygen and moisture, oxygen and water, what happens to this iron? It becomes brown, and this is what the process of rusting is. What is rusting? Let me explain this to you. When an iron object is left in damp air is nothing but oxygen plus water. Right? Basically, if you leave it out for a considerable amount of time, what do you get over there? You get a red, brown, flaky substance called rust. And this process basically is very simply called the rusting of iron. Now, in terms of what is happening with the rusting of iron, very simple. I've just explained this to you. You have iron, which is reacting with oxygen or water, which is basically nothing but damp air. Okay. What is the product that is formed over here? The new product that is formed is iron oxide, right? And this is the process of rusting. Now, rusting is not a very good chemical change. Why? Because things keep getting spoiled. In fact, there are huge losses because of rusting. We use iron to build bridges, and we use iron to build these big ships and structures or cars or whatever. After a period of time, what happens? Because of exposure to air, which is namely oxygen and moisture, or oxygen and water, rust starts getting formed. And because of that, that metal starts corroding. And we can't use those ships in the same way, or use those bridges. The bridges start breaking. The cars don't function optimally. And basically the structures break. So there are actually a huge amount of losses because of this process of rusting. And rusting to hone wala hai na. Why? Because you can't avoid contact with air, right? Or can you? Well, let's talk about some ways as to how we can prevent rusting. We know that rusting happens, but is there a way to stop this or prevent this? Well, yes, there is. I told you that rusting happens because of contact with damp air, which is basically oxygen and water. So if you want to stop rusting, we know that rusting cannot happen without oxygen and water. What can you do? You can stop that oxygen and water from reaching the iron. So what do? We build like a kind of a wall, or we build like a kind of a barricade, which is like a armor plate, okay? This is a Suraksha Kavach. What is that Suraksha Kavach? Basically, you're creating a barrier or a wall between the air, the damp air, and the iron. How can you create that barricade or that wall between the damp air and the iron? Well, one way definitely is to, put a layer of oil or grease or paint over it. Now, what are you doing over here? You're basically coating that substance. You're creating that oil or the grease or the paint. What is it doing? It's forming a Suraksha Kavach between the iron nail. Iron nail is this side. This is your oil, and yahan pe you've got your what? You've got your wait, let me explain this. Let me draw it. I wanted to tell you I'm thinking of something and then I'm thinking of something else. So let's say you have your iron substance over here. Let's say you have a nail. Okay. Now you've got air that comes in from here. Right? Now I'm explaining it properly because now I'm drawing and thinking at the same time. So what do? You basically take some, I'm going to put this for you in a different color. Let's put this in blue. And you basically coat it with some sort of grease or oil or paint or something which basically acts like a Suraksha Kavach, which acts like an armor. And because of that, that damp air cannot reach the iron. Very simple. You're giving it like a jacket. Like I'm wearing a jacket, no, to not feel cold. Like that, you're giving it a jacket so that the damp air cannot reach that iron substance. This is one way. Are there other ways? Again, there are other ways, but basically what are we doing in those other ways also? We are creating a barricade or a wall between the damp air and the iron substance. So what else can you use as a wall or as a jacket or as a Suraksha cover? Well, you could use materials like chromium, which is basically a metal, or you could use zinc, for example, again, where you put this onto the iron, you coat the iron substance with these metals, and this will basically prevent rusting. Now, some of you in our live sessions have gone ahead and asked me questions about the process of galvanization. What is galvanization? Galvanization is very simple. Galvanization is a way or a process of preventing rusting. In this, again, what are we doing? We are putting a coating on top of that iron substance. What is that coating made of? That coating is basically made of zinc. Right? So, the process of depositing a layer of zinc on iron is called galvanization. Just remember, any iron substance, if you put a layer of zinc on it, this is called galvanization. What does galvanization do? It prevents rusting. Very, very simple. And galvanization is actually a process that is used so widely in industrial processes, in factories, in manufacturing, because obviously now we don't want the things to rust. We don't want whatever we are making in the factory to go ahead and rust. So galvanization is used over there. ठीक है? Clear? Okay, let's do a quick summary of what we have discussed so far. So in today's session, we went ahead and we spoke about chemical changes. What is a chemical change? Very simple. Chemical change is one where the chemical properties are altered or changed, and you've got the formation of a new substance. And we know that in a chemical change is irreversible. Obviously, because it's a completely new substance that is being formed over here, right? So this is, we spoke about what is a chemical change. Then we went ahead and discussed what are the characteristics of chemical change. And we spoke about a few examples over here, like the production of heat, light, and sound in fireworks, or the change of smell when we're baking bread or a cake, or a change in color when food gets spoiled, or even the evolution of gas like we saw in vinegar and baking soda, right? Okay, then we went ahead and spoke about rusting. We said that rusting is a process that happens when iron comes in contact with damp air, which is basically oxygen plus water, and you get this reddish flaky substance. This is the process of rusting, and we went ahead and spoke about what are the ways that we can prevent rusting, which is basically oiling, painting, greasing, and galvanization. Remember that galvanization is basically putting a layer of zinc on iron. And with that, we have finished chemical changes. Isn't this an easy peasy chapter? Last time we did physical changes. Today we've done chemical changes. What I want you to do is please go ahead and watch both sessions so that you will understand this chapter in, completely, right? And you will find that it is very, very easy. With that, please go ahead and where will you find the chapters that I'm talking about? Where will you find the sessions? The link is in your description box. We've done a whole lot of sessions for you on so many different topics. Go ahead and take a look at the sessions. Use them to practice, use them to watch, use them to revise, whatever you want to use them for. Please go ahead and do it, because BYJU'S always does a lot for you. Go ahead and use it. Okay? With that, definitely go ahead and subscribe to our 6 to 8 channel. You're going to get all your notifications up there. And that's where I'm going to see you more and more. So this is me, Tarana, signing off and saying bye-bye.